And in this lesson, we are going to go over the last new type of trig equation that we're going to cover. There's only one type, but it gets mixed in with the others, so it can be tricky. And this is fairly new. There's a couple of little tricky parts to it that we really have to make sure we hammer out and that we understand. Okay? Solve each of the following. If x is between 0 and 2 pi, round to 4 decimal places where necessary. Again, it doesn't say this, but it's always expected that you do exact value when possible. And round to 4 decimal places is our general standard when necessary. Okay, so it doesn't say that, but that's what we're going to do. What do you think we do for this? What do you notice about this first one? Honey? It's got a cos 2x, so I wonder if that's going to make a difference or where that's going to come into play and make a difference. Of course, if you read the learning goal, it says I can solve double angle trig equations, so that is what makes this different. But let's find out why and how and what we have to do in order to solve this question. What do you think you might do to start this one? Evan?
Rearrange so cos 2x equals root 3.
Good. So we're going to move the divide both sides by 2 to move the 2 over. Isolate for cos 2x. Cos 2x is root 3 over 2. Now tell me something about this. Go ahead.
Cos 2x equals 1 minus 2 sine squared x.
You could do that. That's not what we're going to do. You could do that. So that was a swap out. Swap it out for sine squared x. In that case, we would then have to rearrange. I guess we take the square root of both sides or something like that and solve it that way. And it would work, although I believe it wouldn't really get us exact values, but that's for sort of a different reason.
Can you do special triangles?
Root 3 over 2 is a special triangles answer. So can't we just use special triangles? Here's the tricky part. Don't write this down yet. If this was cos theta equals, maybe I'll do this in green off to the side. If this was cos theta equals root 3 over 2, then theta related would be what?
2 over root 3.
No. When it's not reciprocal.
Pi over 6.
Pi by 6. So funny. We talked about this the other day, how out of context all of a sudden we start to confuse little bits and details of things. And that just happens. It's just natural. It's so normal. So it's theta related is pi by 6, but our theta is 2x. So in this case, we're going to go 2x related is pi by 6. I put brackets around this. In some cases, you don't need to put the related angle. You could jump straight to the answer if you wanted to. We talked about this before. But in some cases you want to, and because this is new in double angles, I'm going to kind of show it nice and slow. I put brackets around it because it's not 2 times x related. It's 2x all related. What's the difference? The difference is after I've got this part, I do the quadrant stuff. So I get 2x equals pi by 6 for quadrant 1, and 2x equals, what's the other one?
2 pi minus pi by
Which is what?
11 pi by 6.
Good. And then we divide by 2. So this is important. This is a common mistake. People divide at that step and then go to the quadrants. That's wrong. You go to the quadrants first, then divide by 2. Does that make sense? But there's more. We're not done yet. And this is how I like to think about this. What is the graph of cos 2x? What's the graph of cos 2x? Come on, this is We know this. In other words, what's a 2 do to the graph? Evan?
That's it.
Compresses it. So normally this point here is what? With no transformations, it's 2 pi. But if we're compressing it, that's going to be pi. Right? And I found these two answers. Because 11 pi by 12 is less than pi. Do you agree? It didn't say to solve up to pi. It said to solve up to 2 pi. Where are those? If this is root 3 over 2, this line, and it's cutting that graph of cos 2x 4 times, shouldn't there be 4 solutions? Like, this is what we've been talking about for the entire course, is how graphing and visualizing helps inform the algebra and make sense of what's happening here. Do you agree? There should be 4 answers. So how are we going to get the other 2? David?
Could you multiply the ones on the bottom by 2, but that would make the pi by 6 answer?
Yeah, and that's not going to be over here, is it? So you got the right idea, but the wrong operation. Evan, what were you going to say?
Could we add pi?
We could add pi, because it's just the period of cos 2x over again, right? So going from here to here, if I add pi, I'll get that next one, and same things going from this one, adding pi, I'll get that next one. Okay, so we got one extra step. (11 plus 12 is 23). And for these ones, I recommend a summary, because what happens is we get a sort of mess of answers all over the place, especially if you're not organized in your work. You might have answers kind of all over the map. And so it's good to summarize. And if you could write them in order from smallest to biggest, that'd be great, because that just makes my life easier. And we got 4 answers. What do you think? Questions about that? So folks, as I said, common mistake, dividing at that step. So you got to split it up into quadrants first, then divide. Then all you need to remember is that you have to add pi to each to get the other 2 answers. Okay, so like, you know, it's not that much different than what we were doing before. But there's a couple of extra steps and a couple of little details that you have to remember. On yesterday in the lesson, one of the swap outs was cos 2x. And as Evan said, you could swap out here and you'd have a squared, so we would end up with 4 answers, but I don't think we would have got them exact. So a question like this on the test would be expected to solve this way. But there are some questions that are swap out that have double angles in them. And when you do the practice for this, you'll notice that there are some questions that have a 2x or a 2 theta in them, and it's a double angle, and some that has a 2x or a 2 theta, but it's a swap out. So again, that's part of knowing the different types and when you have to do which one or the other. Okay, another one, 3 cosecant 2x equals 1. So this is reciprocal. So we'll divide by 3. Then what do we do?
You flip it and get sine 2x equals 3.
I think this is almost like the identical one, except not obviously with the 2x as the one we did yesterday. And so what happens?
No solution.
No solution. So having a double angle doesn't impact the amplitude. So that part stays the same. Kind of interesting, we didn't look at the graph of cosecant or secant very much, but it looks like this, where that value is 1 and that value is -1. So whereas sine can't go past +1 or -1, cosecant can only be can't be within 1 and -1 and can only go outside those bounds, right? So when you get a fraction here, that's going to end up being, or like a fraction that, or a decimal between -1 and 1, like 0 point something. Those are going to be the ones when you flip it that they're not going to work. Okay, so let's change it. What if we change it to this? What if we change it to cosecant 2x equals 3? Then when we flip it, we get a third, and we can do it. What's going to happen with this one? Like, how are we going to do this one?
With like the 4 decimal places in the numbers.
Yeah, it's not an exact value, so we're using our calculator for this one. Okay? So again, 2x related. It is inverse sine of 1 divided by 3. Obviously, you don't have to write down that line. I'm doing it because, again, like, this is stuff that you've already done, but it's so funny how in a different context you start to second guess, because right now your brain is concentrating on this new information. It's harder to sort of retrieve the other stuff that it needs, the understanding and knowledge and processes that it needs to do this, until it becomes more familiar, I suppose. Okay, got to get my calculator back out. Make sure it is in radians. Shift sine 1 divided by 3. So I get 0.3398. This was sine, it was positive, so I'm going to go to quadrant 2, so I'm going to do pi minus. But you know what? It might not be a bad idea. Oh, let's do that. Let's do pi minus, shift pi minus, and get this one. I don't really want to flip back and forth between these two, though, because the calculator work is kind of messy. So I think it kind of makes more sense to go all the way down this side first and then go back to the start and go all the way down that side. Do you know what I mean, with your calculator? So now that I'm on this side, I'm going to do that, because I'm going to go take that answer and divide it by 2. The last one we could do kind of in our head because it was fractions, radians. So x is 1.4009 and x is going to be 1.4009 plus pi. So again, now I can just do plus pi. Then I got to get theta related back. And so now I've got my quadrant 1. I can divide by 2. And add pi. Don't get confused and think, oh, these answers are all too big, so no solution. No, 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 no. The angles can be whatever we want, right? Therefore, x equals 0.1699, 1.4009, 3.3115, and 4.5425. You want to remember that you should have more than just two answers. So if you get to the end of this question on the test and you only have two answers, you might say to yourself, is there a reason why I only have two answers, or have I forgot to do that last step kind of thing, right? Be aware of how these should work out. We're going to do another one. Any questions before we move on? One more, I think. All right. So what's this one? What's going on with this one? What's different?
Quadratic.
It's a quadratic. How many answers does a regular sine theta question, like sine theta equals a half, how many answers does it have from 0 to 2 pi? Maddie says 2. Is that right? Yep, 2 answers, right? Quadratics generally have 2 answers, or can have 2 answers. So how many would that make? How many answers total would that make? 4. But if it's a double angle, how many answers is that going to make? That's going to be 8 possible answers to this question. Yikes. What's going to be our first step?
We see if it's factorable. And
Thank
then
you very much. B squared minus 4ac. Did you do it?
yeah, I got 25.
25. So b squared minus 4ac is 25. So this is factorable. So we're going to factor it. And it's going to be 1 and 1. And it's got to be 3 sine, careful, 2 theta and 2 sine 2 theta. And it is going to be minus and plus there. So it's negative 3 sine 2 theta plus 2 sine 2 theta, which gives you the negative sine 2 theta. Therefore, sine 2 theta is negative 1 over 3. Sine 2 theta is a half. Tell me something about these 2 answers. Maddie?
The one we can use special triangle.
And the other?
Is like the other way with the.
Yeah, we can't. In other words, we can't, right? So one's a calculator and one's exact value special angles. Let's do the special angles one first. That's the easy one. So 2 theta related is pi by 6. Remember, you got to split them first. So 2 theta. This one's positive, so is pi by 6. And 2 theta is going to quadrant 2, 5 pi by 6. Now we can divide by 2. So that's 1 plus 12 is 13. Five plus 12 is 17. Yes?
Is there a reason why we did 5 pi by 6 on the other side?
Quadrant 2. It's sine and it's positive. It was sine 2 theta equals positive a half. Okay, and 2 theta related. Is everybody good? Everybody's got that okay? So the other one's calculator. Shift sine 1 divided by 3. So we've already done 1/3 with sine, but this one is negative. The last one was positive, so we're going to the other two quadrants. So it's going to be the same related angle and kind of look similar, but 0.3398. So this is where I'm going to go down one side first and then come back and go down the other side. Because otherwise you're just going to have to keep typing stuff back in or whatever. Like it's going to be way more work, right? Oh, so I'm going to start with quadrant 3, I guess. Sine is negative, so we're going quadrant 3 and 4. So to get the first one, we're adding pi. Divide by 2. And add pi again.
Why did you add pi first and then divide by 2?
Because I was going to quadrant 3 and that's pi plus theta related.
But don't you divide first?
No, you don't divide first. I took theta related, took it to quadrant 3, not theta related, 2 theta related, took it to quadrant 3, and then you divide by 2. .8823, back up to the other side. So this is where now I have to go all the way back up to where I calculated 2 theta related and go to quadrant 4. And I'm going to run out of space here. So now I'm doing 2 pi minus 5.9433 divide by 2. 2.9717, add pi to get our last one, whoops. And so if you do it that way, then you're never like erasing your calculator and starting again. You can just, except for the one time, I guess. You don't have to put all these in order. Just put the fractions in order and the decimals in order separately. And now I have a cramp in my hand. Oh. Get your related angle, which we call 2 theta related. Quadrants first, then divide, then add pi to each. Questions? Everybody good? There's one other little question on this, and it's not something that we're going to actually answer. You don't really even have to copy it down, but take a look at that. Cos 3x minus 1 equals negative a half. You could try to solve it if you want. The question is just, and I don't want anybody to shout it out, but the question is how many solutions would it have? So it's something that you could think about.